Welcome everyone to today's webinar. We're going to talk with one of the principal analysts that is covering the Edge ML space, and we're lucky to have him with us, and we're going to cover what it takes to actually accelerate this huge movement around Edge ML, Tiny ML, and what it actually takes to get things deployed in the field. So I'm excited to have with us Lian Jye, principal analyst from ABI Research. And thank you, Lian, for participating and for being with us. So I'm going to actually, before passing the mic to you, what I'm going to say is that we're going to be presenting, or Lian is going to be presenting, and then after that, we'll take questions. So feel free to ask any questions in the chat. We'll take them towards the end when Lian is done, and we can then have an open chat about other things as well. So I'm excited about this. Over to you.
Likewise. Thank you, Alessandro, for the kind introduction. Hi, everyone. My name is Lian Jye Su. You can also call me LJ. I'm a principal analyst at ABI Research, leading our AI research service. So as machine learning continues to mature and gaining momentum, bringing ML to the edge has become a key focus for many enterprises. Today, I would like to take this opportunity to discuss Edge ML market, its current state, how it is evolving, and then what are the key factors that will propel the industry forward. This slide sort of briefly shows the outline of today's webinar. I will provide ABI's research definition of edge machine learning, and then I will be introducing the key market verticals and spend a bit of time discussing the role of tiny ML and distributed computing, such as gateways and on-prem servers in edge ML. Then finally, I will discuss the key success factors in accelerating edge ML deployment. First, what is edge ML? So we at ABI Research define edge ML as all ML workloads that take place outside of hyperscale cloud infrastructure. So sort of to provide a more granular view of the market, our research segment the market into four main segments. So namely tiny ML, on-device ML, gateways, and on-prem servers. So let's start with tiny ML. This refers to ultra-low powered ML inference on either smart sensors or devices powered by MCU, or even in some cases DSP. We expect this market to be a very significant one in 2022, with close to 1 billion units being shipped into both consumer and non-consumer market. Next up is on-device ML. These categories spans across a diverse range of devices, big and small, ranging from smartphones and wearables to mobile robots and autonomous vehicles. ML-enabled devices are usually equipped with a CPU and then being augmented by either a GPU, FPGA, or ASIC for on-device ML inference workloads. With the emergence of new ML techniques, such as federated learning and swarm learning, some of these devices moving forward will be also able to perform ML training at the edge. But these cases is still fairly immature, and I think it's very far and few between. In our opinion, gateways and on-prem servers are becoming an essential enabler for edge ML. While it is true that more and more devices nowadays are shipped with embedded ML chipset, companies and enterprises are also looking for other ways to add ML capabilities to their legacy equipments. They can actually connect these legacy devices to gateways and on-prem servers that are equipped with ML chipset, and in doing so, they can actually run ML inference and even sometimes ML training without the need to transfer everything to the cloud, and then relying solely on cloud computing services. Why do we need edge AI? Well, traditionally, ML training and inference workloads are centralized in the cloud. This is mainly to leverage the flexibility and scalability offered by cloud computing architecture and solution. As such, the entire AI industry has been quite well served by cloud-based AI solutions. So you can think about Alexa and Google Assistant in smart devices, cybersecurity systems, and also recommendation engines that's hosted in the cloud. Under cloud AI, end devices only need to acquire data and send them to the cloud for processing. All the ML training and inference take place in the cloud. This makes sense because of the low computing costs provided by the scalable and flexible cloud computing architecture. Unfortunately, this approach to ML is at the mercy of connectivity and security. It's also sort of being limited by multiple factors, including geographical data sharing limitation, connectivity costs, as well as of end node processing capabilities. So in recent years, the industry has witnessed a shift in the AI paradigm. AI workload nowadays are slowly moving to the edge. More and more edge devices nowadays are featuring edge ML chipset that can handle ML inference workload. As compared to the cloud, edge ML actually brings 4 significant advantages. Number one, edge ML guarantees a much better user experience and responses through low latency. Number two, keeping data processing at the edge ensures privacy for mission and business critical applications. This includes applications such as facial recognition and voice biometrics, as well as all ML applications that are using sensitive personal identifiable information or PII. Number three, ML hosted at the edge is far less reliant on the constant connectivity to the cloud because edge AI is able to process data locally, freeing devices such as vehicles, robots, and drones from constant cloud connection. Finally, number four, edge ML allows enterprises to make sense of the mountain of data that they collect from end devices. This allows them to make better business decisions based on daily operation, usage trends, and consumer behaviors. Driven by the need for privacy, cybersecurity, and low latency, the entire AI industry is looking to perform ML training and workloads on gateways, devices, and sensors. And given the advantages that I mentioned just now, we at ABI believe that the overall edge ML market will reach close to $38 billion by 2026. Moreover, the install base of devices with edge ML chipset will be expected to exceed 5.5 billion by 2026. This is sort of driven by growth in consumer devices, smart homes, industrial manufacturing, as well as transport and logistics. Furthermore, as enterprises start to look for near real-time image and video and language processing, the sale of edge ML chipset will exceed that of cloud ML chipset by 2025. Aside from chipset, edge ML development software and turnkey services will become the new growth market. One of the most common challenges with edge ML nowadays is the lack of talents among enterprises. And even when a particular enterprise has the right means of monetary and data resources, they often struggle to hire great ML engineers. It is extremely difficult for them to compete with cloud AI giants and Silicon Valley startups. Sort of by leveraging ML solutions and services offered by third-party software and service vendors, enterprises can actually significantly accelerate their edge AI deployments and thereby reduce time to market. Here, I would like to take the opportunity to sort of discuss several key edge ML markets. The first is quite obvious, it's personal devices. Previously, sort of edge ML capabilities are limited to premium smartphones, but I think nowadays it is sort of coming down to mid-range smartphones, premium laptops, tablets, and webcams. I think most audience are very familiar with the innovation coming out from Qualcomm and Huawei in this space. But in 2022, laptop and PC OEMs, for example, are actively partnering with other chipset vendors such as Lattice and Emza to integrate AI-based machine vision into their premium laptops. The ML models are enabling fairly innovative features such as facial tracking and authentication, presence detection, power optimization, and much more. Wearables is another crucial domain that Edge ML tech suppliers has been targeting for years. Hearables are actually becoming more accurate due to the audio enhancement, noise suppression, and voice recognition capabilities brought by Edge ML. Battery-powered devices, particularly in healthcare, they are equipped with tiny ML sensors, can now process data at the edge without needing to send the data to the cloud, allowing healthcare organizations to comply with data protection and privacy requirements. In many industries, large companies in this are also actively deploying automation technologies. This includes solutions such as mobile robots, ASRS, and drones. And these provide solid foundation in creating sort of a highly automated dark warehouses and factories, which is a critical step towards building a strong supply chain resiliency and reliability. Companies such as NVIDIA and Cylix are actually introducing ROS-optimized robotics platform that can accelerate robotics design and development. Turning our attention to sort of industrial manufacturing, which is also another heavy user of Edge ML. Key use cases includes anomaly detection, condition-based monitoring, and visual inspection. Many tech companies recognize the opportunity in this domain, and moving forward, we do expect key use cases such as predictive maintenance and overall efficiency enhancement, OEE, to become critical use cases. Already, we are seeing a combination of video, audio, and time series sensor data being used to generate a better picture of the operating environment. End users are also actively deploying smart industrial gateways with Edge ML chipset and software to make brownfield infrastructure smarter. In smart cities, governments around the world are actively deploying smart infrastructure to make cities more efficient, sustainable, and resilient. Edge ML can be found in security cameras, public utilities, traffic systems, patrol robots, and drones. The insights generated by all these Edge ML devices can also be shared across multiple agencies, thereby creating faster response and database decision making. Another very interesting vertical is retail. As traditionally a very labor-intensive industry, retail players are now actively deploying smart cameras for theft monitoring, and also mobile robots for floor cleaning and aisle scanning. In addition, automated stores are becoming more and more common as they combine multiple Edge ML technologies into an integrated solution that offers seamless checkout experience in unmanned retail stores. In recent years, as I mentioned earlier, Tiny ML has become a key enabler for Edge ML. Traditionally, embedding ML in ultra-low power devices is an extremely difficult task. The end user needs to have a blend of expertise in embedded system design, on-device ML, model optimization, and compression. To sort of overcome this challenge, Google launched a low-power AI processor and an AI framework that's optimized for ultra-low-power environment that kickstart an entire movement towards putting Edge ML into smaller and smaller devices with very small energy and storage footprint. ABI Research estimates that there's going to be a close to 1 billion global shipments by 2020 across a wide range of verticals. It is also equally important to note that Tiny ML can also be deployed in existing equipment that runs on microcontroller. And this actually makes legacy devices smarter, greener, as well as extending their existing useful lives. Another key trend that has emerged in recent years is the introduction of distributed computing. As mentioned earlier, computing resources are no longer limited to public cloud and end devices. More and more workloads are being currently distributed across the computing value chain, acting as sort of the middle layer of that interface between end devices and cloud. Gateways and on-prem servers are actually excellent option to perform ML inferencing and training. They can also make legacy infrastructure smarter and allows companies to not just avoid replacing all their old equipment, but also helping them to reduce their TCO as all this legacy infrastructure can remain in service for many, many years. In addition, these gateways and on-prem servers can provide an extra layer of security protection, helping end users to adhere to good data governance practices. So to sort of support the wide range of use cases and verticals that I mentioned previously, the edge ML industry requires the right type of processor to resolve all this concern around power consumption, data privacy, low latency, and high performance, while also providing excellent security. The developers are increasingly relying also on edge ML software support from various processor suppliers to accelerate edge ML deployments. Currently, what we are seeing is that GPU and FPGA is sort of commonly deployed in use cases that require high performance and flexible computing resources, whereas for use cases that requires low power consumption and high optimization, ASICs and MCU are the preferred choices. In the long run, we foresee ASICs to be the more and more mainstream option for use cases that requires to scale up and has large market shipments. But at the same time, GPU and FPGA will continue to remain a crucial part of ML applications, particularly those that requires more computing resources and flexibility. Devices with edge ML are notable in being able to capture all type of data for analytics. This is especially true for enterprise that are looking to use dark data for their solution. When utilized correctly, the dark data will be able to provide valuable insights and being able to provide a new perspective on the operating or the production procedures. That data can often be found in critical equipments that are not previously connected to the industrial internet. But at the same time, it is also important to highlight that not all equipments can generate a large amount of data. Some devices only generate data in large cadence and much lower frequency. But in those cases, as long as there's a good edge ML model, we can still make sense of situation that has that only generates a small amount of data. Lastly, edge ML models are also being increasingly designed to handle data with multimodality. A combination of audio, image, and time series data generally provides a much richer information of either the performance of an equipment or a situation detected by a video stream or in autonomous driving. As we mentioned in previous slides, data is essential to a successful ML project. However, even in 2022, companies often do not have good data management and governance practices. Most, if not all, data protection regulations nowadays still focuses on personal identifiable information or PII. But as enterprises seek to digitalize their existing workflow, what we are seeing is that they are adopting emerging technologies such as IoT and Edge ML. And this has sort of led to the rapid growth of other data types, including machine-generated data, geospatial data, and synthetic data for data science and AI model training and testing. If these type of data are not handled correctly, they will be prone to abuses and cybersecurity hacks. They may, I think, more importantly, result in biases and shortfalls in Edge ML models. So it is important to ensure good data operation that helps to collect, prune, and prepare data for ML training. Most importantly, the ML end user themselves must be able to demonstrate that they clearly understand the limitation and the insufficiency within the data that's being used for Edge ML model training. And this can actually be mitigated or addressed through sort of a few approaches. So like traceable and version controlled databases, clear data ops guidelines, and the right organizational structure with participation of data protection officers. Another key ingredient is actually user-friendly tools and services. This includes tools around data management, model generation and onboarding, model optimization, model governance, low-code or zero-code deployment, and AutoML. It is obviously very clear that enterprise needs proper data management tools to collect, track, and label data. But then once you have the data in place, enterprise still need to identify the right machine learning models, and then need to train it, tune it, and optimize it for the preferred hardware environment. Having a model library that helps to suggest the most suitable model and the right optimization strategy, it's extremely crucial. And this is why sort of advanced feature like AutoML is extremely beneficial. AutoML automates vital steps within the ML development process, including data preparation, feature engineering, model selection, hyperparameter optimization, and pipeline selection. Of course, developers who develop their own proprietary models are also welcome to bring their proprietary data and algorithms to the existing platforms out there. There is an increasing popularity around supporting developers who have their own data and algorithms. Since not every ML implementers are data scientists or ML experts, vendors will also need to be able to support low code or zero code development. And once an Edge ML model is deployed in the field, enterprises will also need software and services that enables them to monitor for drift and biases in their ML model to maintain accuracy. Lastly, in some cases, enterprise could actually benefit from a very comprehensive use case specific Edge ML solution. Many ML projects unfortunately struggle to move past the testing and trialing phase because it does take a lot of effort to identify the right type of interfaces, middleware, frameworks, and monitoring solution for Edge ML. At the same time, investing in an Edge ML development team with a wide range of skill sets across data science, firmware, and software technology will result in very heavy investment and long development cycles. So, based on our experience, we believe that the Edge ML solution from third-party service providers can greatly reduce complexity, accelerate Edge ML design and operations while providing cloud-based device monitoring, orchestration, and model retraining support. So those are quite critical in advancing and lowering the barrier for Edge ML. And this is the final slide of this presentation. I would like to conclude this entire presentation with a few key takeaways. First, having a clear ML vision is a must for companies to stay competitive, efficient, and resilient. Edge ML is a key complementary technology for advanced automation such as dark warehouses, autonomous factories, and unmanned retail stores. Second, TinyML has immense potential beyond the existing consumer markets, especially in healthcare and industrial applications. Third, AI-enabled gateways and on-prem servers are critical in protecting the useful lives of our brownfield investment. That goes also to TinyML as well. Fourth, enterprise should never underestimate the complexity of data operations and edge ML ops. So that's why, last but not least, when facing sort of development challenges, companies must be wise and must be keen to identify the right solution partners that can provide them with the right set of capabilities and guidance. This is all for my presentation today. I thank you very much for the attention and love to answer any question that you have. Over to you, Alessandro.
Thank you, LJ. Thank you for the great presentation and for a lot of great insights. I'll leave the slides on because I actually we might want to refer back to some of the slides. So, you know, I've got a couple of questions queued up, and before kind of going through those, I'll remind the audience that if you do have questions, feel free to post them in the chat, and we'll take them and address them live here. And if you're watching, you know, this afterwards, then unfortunately you'll have to live with the questions that other people asked. So let's start with some questions that we had queued up here. So initially, so you mentioned there is a lot of barriers to developing machine learning models, to actually collecting data in the first place and deploying these models to the to actual in-field deployments, right? You had slide 13, I think, that was quite a good overview of the whole cycle. So maybe we can go back to this. So I'm curious, you know, I know that you're doing a study looking at different vendors, different tool vendors, and I'm curious to kind of hear your thoughts on the differences and perhaps, like, you know, give an overview of what you're seeing in the market, what is having more traction, where the kind of benefits of the different opportunities are, or the different offerings are.
Yeah. So I think what is quite popular among sort of enterprise nowadays is AutoML. I think, as I mentioned earlier, I think not all ML implementers are sort of data scientists or ML engineers. So they actually appreciate sort of assistance provided by the software vendors to sort of allow them to identify the right optimization strategy, the right compression techniques to sort of seamlessly deploy the ML model onto the production equipments. I think the other thing that is quite crucial to lowering the barrier is sort of assistance in the data management side of things. I think a lot of companies don't really know what type of data to collect because I think they often know that they need a deep learning model or they need a neural networks to address whatever challenges that they have without understanding the sort of the basic ingredient, which is the right data. I think many enterprises assume that they have tons of data at hand, but I think in order to achieve the right accuracy and the right performance, you do need to sort of capture the right type of data. And I think so sort of like that type of advisory and sort of guidance in terms of how to collect the data, how do you prune it, how do you store it, and then how do you use it for training and then for testing. Those are quite critical.
Yeah, awesome. And looking at obviously what we offer most of the things you mentioned. So I'd be curious to kind of maybe hear your thoughts on the key points that Edge Impulse can address in solving these barriers, right? Do you have any thoughts on that?
Yeah, I think one thing that I think is a very encouraging sign is that Edge Impulse has sort of are sort of offering use case specific solutions to enterprises. To me, that is a great way to sort of help the enterprise to speed up their adoption and deployment of Edge ML. I think a lot of times with sort of just the development platform. Many companies they may use the platform for experimenting or for trialing, but it can be rather difficult or even rather daunting for them to move from trialing phase to the production phase. And I think with Edge Intel's capability in across all the sort of suites of solutions that you guys offer, you are in the best position to sort of package that and sort of offer to the client the right path towards production. I think that approach, I'll be very honest, is sort of increasingly being viewed as the sort of like the most successful way to accelerate Edge ML deployment.
Awesome. Well, thank you for that answer. We have a question from Zach. I think we've covered most of it, but perhaps I think what's interesting here is that Zach is asking, what are the barriers to faster uptake of Edge ML technology in enterprises more widely? What can the industry and the vendors do, right? So we've talked a bit about this, but perhaps there's more you can say about the industry as a whole, right? Like what should what kind of approaches should the industry take and the vendors, and what differs between them?
Yeah. I think for the wider industry, they also need to understand sort of what is the right type of use cases that they want to address. I think a lot of times some companies may want to do a lot of stuff at the same time, but sort of having a very clear vision that, okay, this is the let's say we want to do predictive maintenance first, and just focus on that before looking at other things is very critical. Like having that use cases clearly stated and then clearly communicated from the top management all the way to the production team, and get everybody on board. And then after that, you need to also understand what are the sort of the limitation that a company will have to deal with. Sometimes it's data related, sometimes it's hardware related, sometimes software. So I think having that understanding, having that mindset to sort of come up with the right solution is crucial. And then the other thing, which is also quite important, which I didn't highlight in my presentation, is that Edge ML ultimately is a multidisciplinary sort of task. You do need to involve people from multiple facets of your operation. It will be sort of like the people who is handling the equipments, the IT team, the data scientists, all the way to the C-level people. So having everyone sort of collaborating and then talking to each other at the same sort of understanding, and then sort of agreeing to the same set of KPIs, I think those are very, very critical in helping to bring down the barriers of adoption.
Yeah, very, very good answer. You addressed the challenges around the infrastructure and the data collection and the life cycle of the data. And I think, it's interesting that you now mentioned how many people are involved in an ML project, right? And how many different specialties it requires, right? And I think, the infrastructure is really what kind of keeps all these people kind of in line and enables people to share data across the enterprise, enables multiple aspects of the enterprise to kind of connect and talk to each other and work together. So I kind of feel that I feel the same way. I think it's really important to be trying to solve these challenges together as an enterprise. So really good answer there. We have an interesting question from Jacqueline around the environmental sustainable goals, the ESG, and she's asking, how can edge devices in ML be used to meet the ESG? Do you have any thoughts on that? How can ML solve sustainability?
Yeah, no, that's a very interesting question. I think there's probably a couple of ways where Edge ML can play a critical role. I think probably the most obvious answer to this is that I think when you sort of started to deploy a lot more sensors, especially smart sensors, in sort of public sectors and sort of factories and production sites, naturally, like more data will get collected, and then people will be more aware of, let's say, their carbon footprint, or sort of the lifespan of their existing equipments, and this sort of allows them to sort of really monitor what goes into the production, and then what then get released to the atmosphere, let's say. But I think there is a sort of deeper layer to this as well. So when we talk about being green, it's not really just the carbon dioxide that's being released during the production phase, but it's also the large amount of new products that we ship on a yearly basis. So if we are able to sort of extend the lifespan of existing equipments just by making them smarter, this can be achieved, for example, through TinyML, or through sort of the gateways and the on-prem servers that I mentioned earlier, that can actually help to sort of make the existing lifespan much longer, keep them in operation beyond sort of the need to replace all these machines just because they are not, let's say, smart. I think that can actually contribute a lot to the ESG goals.
Yeah, it's a very interesting question. It's always something that I keep in mind. I think as an industry, we have to do more, and it's interesting that EdgeML, as you mentioned, can solve or can help to address some of the challenges. I mean, one of the interesting things is also, I think you mentioned at the beginning of the presentation, is around the power efficiency of edge devices, right? Where you can stop yourself from sending everything to cloud. You can process things on the edge, and that alone already kind of helps if you obviously are kind of conscious of where you're deploying things. But effectively, that's already I think a big benefit. So that's great. Thank you for that answer. One more question. So we went through some of the kind of high level verticals, but we didn't really deep dive into the use cases. So I wonder if we can go back maybe to the slides and maybe kind of walk through some of the use cases that you're seeing more often in those different spaces. So maybe let's start from the wearables. Yeah, wearables.
Sure.
Place. Yeah.
I think wearables is an interesting one. I think nowadays, I think at the moment, a lot of the analytics being are still being done in the cloud, quite similar to smartphones. Just because wearables in and of itself does not carry a large sort of a battery to support high performance chipset. But I think that's something that TinyML can definitely address. So obviously, it has to be very application focus. It has to be focused on maybe just a single application. So in the case of, let's say, true wireless earbuds, most of the true wireless earbuds nowadays are equipped with noise suppression, with voice recognition, and perhaps moving forward with voice biometrics as well. Similar stuff, I believe, will be coming to healthcare devices, particularly sort of personal healthcare devices, where simple diagnostics can be run on the device itself. Now, the challenge with healthcare is that there's always a regulatory component to it, and there's something that I do believe will get resolved as sort of people are more and more exposed to Edge ML, and then are comfortable with the way that data is being handled. I think that's why I was sort of stressing earlier on, is that it's rather important to have a very strong focus on sort of data privacy and data transparency, and sort of how data is being managed during the ML training process, because that will actually create sort of more confidence among end users, and sort of eliminate some of the fears that people were talking about when the devices are sort of using personal data for training and inference. So that's for wearables. I think the other market that I'm personally very excited about is mobile robots. I think for mobile robots, what is interesting is that at the moment, most of the AI computation are mostly focused on SLAM or sort of localization and navigation. We do believe that as we move forward, robots will be used for a wide range of applications. Already, we are seeing robots being deployed for floor cleaning, for infrastructure inspections. Those are relying heavily on computer vision. But I think moving forward, there will be a combination of use cases that can be enabled on a single mobile robots. So you can think about robots being deployed for floor cleaning that can also at the same time doing aisle scanning, also doing sort of a security task, which previously was not being able to do or not being able to achieve because of the limitation of the computing resources that's available on the robot itself. Also, at the same time, I think there are others of emerging technologies that is helping this trend. So if you think about 5G, if you think about Wi-Fi 6, or even edge computing, so basically technologies that can provide edge-based, very localized processing capabilities at sort of a near real-time latency. I think those will greatly accelerate sort of the deployment of mobile robots across multiple industry.
Awesome. And I think one question that come to mind from all the different conversations I'm having with different enterprises involved in this space, there's always doubts around like the quantity of things that have been deployed so far, right? I wonder if you have any data around the number of kind of use cases that are actually in deployment today, and how that trend is evolving over time. I mean, even if you don't have like exact data, but like, do you have any sense of the growth of the actual use cases being deployed versus the chipsets that you mentioned earlier?
Yeah, so I think I would say that based on what we are seeing right now, I think the sort of chipset versus use case ratio is probably like 1-to-1. We are, I think, at the stage where most of the chipset are still sort of being very sort of task focused. So if you can see, based on our forecast, I think we are looking at a pretty sizable amount of shipments. I think I sort of mentioned that by 2025, the edge ML chipset shipment will overtake cloud ML market. But then as sort of the chipset becomes more and more complex and more capable, they are actually able to handle multiple use cases. So then in that case, it will be sort of the obviously the ratio will change. But also, I think what is interesting is that there's going to be a change in how ML chipset is being deployed on a device. I think right now what we are seeing is that a lot of the ML processes are being processed in a centralized manner. But I think as we move forward, there's going to be a more distributed, also domain-specific type of approach, where let's say for autonomous vehicle, the car itself will have multiple domains that handles either the infotainment or the telemetry or the sensor fusion. And then they are also responsible for their own AI workloads. And then obviously then you can either have a centralized or decentralized AI processor that handles let's say the ADAS algorithms. So I think those are some of these more interesting trends that we do foresee coming in the next few years.
Awesome, thank you. Really cool. And yeah, I think we've covered quite a lot. I don't see any. Actually, do I see any more questions? Oh, there is
Yep.
one question from David here. Key takeaway slide, last line. What are some important considerations a company should have when identifying, vetting a potential solution partner?
Yeah, so I think it's about sort of something that I mentioned earlier. It's about that communication. I think because it is not easy for a company to deploy Edge ML. It involves a large multidisciplinary team within the company itself. It requires the sort of partnership and collaboration across multiple departments, and then as well as with the solution partner. So it really what's really important is that the solution partner must be able to demonstrate, I think, first of all, domain expertise, so that partner needs to be sort of be able to speak the language, and then to sort of understand the common, let's say, use cases or the common challenges that the industry is facing. But then also at the same time, the partner must also demonstrate a wide range of expertise across hardware, software, and sort of system integration, because HML at the end of the day is not a single challenge. It's a multifaceted challenge that requires multiple skill set. And the fact that a company is already looking for a partner means that the company acknowledges that it doesn't have the internal capability to do so. So having a partner that demonstrates, I think, both domain expertise as well as sort of a wide breadth of understanding across hardware and software are actually very, very critical.
Awesome. Thank you for that answer. And we have another question actually from LinkedIn. Yep. With chip complexity to attend multiple solutions, we normally incur in greater power consumption. How do you see this being handled in the future?
Yeah, I think that's a very interesting question. I think the chipset industry itself, it's acutely aware of the the trade-off between performance and power consumption. I think increasingly, companies like ARM, they are introducing ultra low powered processing cores for AI processing. But then at the same time, I think there is an attempt to move the ML processing closer and closer to the source of the data. So let's say in some cases we are talking about a smart DSP that's being able to process audio signal directly on the DSP itself, instead of having that data being sent even within the chipset to a dedicated NPU, let's say, for processing. I think having a sort of like a stage approach to ML workloads is actually quite crucial to reduce energy consumption. So let's say you have a smaller ML model that can run on an always on type of condition, and then that is able to filter all the sort of the non-critical information and only wakes up the MCU or the NPU when there is a critical situation. That will actually greatly reduce the overall power consumption and power footprint. And I think that's probably the current way of doing things. I think moving forward, there is, as I mentioned, like a domain type, sort of domain specific AI processing that I mentioned earlier. That is also another way to sort of how you sort of reduce that power consumption.
Very good. I think we're almost at the top of the hour. Is there anything else that we didn't cover that you were thinking or you think it's interesting to cover? Given that we have a couple more minutes, is there any aspects that you wanted to dive more into? I have one thing. One more. I guess there was one more use case that we didn't cover. Smart city. Or actually, even industrial, we didn't really go into that. But I'm curious, actually, maybe across the board, which vertical do you think will have more? Where will there be more traction? In which vertical do you think EdgeML will have more traction?
Yeah, I think there's probably like there's a couple of verticals that I'm looking at very, very closely right now. Obviously, smart city is one of them, but then because already we are seeing a lot of smart cameras being deployed by different government agencies. There is a huge push towards sort of adopting edge computing infrastructure, so be gateways or on-prem servers across multiple cities. But I think equally, industrial and manufacturing is also gaining a lot of momentum. But I think one industry that I paid really special attention to is probably healthcare. Like if healthcare industry is able to get by the concern around privacy and the regulatory restrictions, that is going to be like a huge market for HML players. Just simply because there's this constant need to deliver sort of cost-friendly healthcare services to citizens, but then also at the same time being able to be very smart in terms of how you deploy healthcare for the underserved or sort of underprivileged community. And I think that is sort of the other humanitarian aspect of HML, which I didn't touch on much earlier. So similar to ESG, similar to sort of carbon footprint. I think at the end of the day, HML is just another technology that is being used to advance human well-being. And I think use cases like healthcare, like green industry and green technology are the ones that I think would benefit the most from just having HML, because those are the stuff that is traditionally rather difficult to do with the existing solution that we have. And I think having HML in those industries will definitely propel the vision forward.
That's an awesome way to end. Actually, I think giving the power to the people, and as you mentioned, using technology to better everyone's life. I think that's a really good goal to have in mind when we build technology. And it's cool to know that this technology can actually be helpful in a lot of different ways. So I'm excited about that. I'm excited about the next few years, and actually the fact that you mentioned earlier that one of the things that really hit me is the number of AI edge chips will surpass in 2025 the number of cloud chips. Right, that's unbelievable. I mean, a few years ago, I think nobody would have expected that. So it's quite interesting to think of that. It's quite interesting to think about how much more edge ML can happen and what it could actually mean for everyone, right? Like what it can enable, how much power reduction there could be, how much more maybe usage by, as you mentioned, all sorts of different people across the world. You don't have to rely on central repositories of knowledge and of data and processing as well. So that's really cool. Very cool. Thank you so much for your time.
Thank you so much as well.
Else? Yeah, is there anything else that you wanted to mention, or anything that you want to leave the audience with?
I think nothing in particular, but other than the fact that I think it's quite important to stress that I think sort of taking that first step in edge ML is usually very daunting and full of uncertainty. I think that's something that we have. I think the industry has not stressed enough sometimes because I think we are very focused on the benefits and the potential, but it's quite, I think, commonly acknowledged that most ML projects does fail in the early stage. But I think that is actually why sort of companies like Edge Impulse is very important. I think being able to be there for companies that are first trying out the technology, but also being there to help them with the future deployments and the monitoring, and then be able to scale up the Edge ML solution. I think a sort of having sort of that expertise is actually quite crucial, and will definitely help the industry in sort of democratizing HML.
Very good. Yeah, we're doing our best to democratize HML for everyone, and hopefully will be, it'll grow as you're suggesting, and will be helping a lot more developers developing things that can actually be deployed in real world projects or end products. So that's
Sounds
really
good.
cool, really exciting. Thank you, LJ, for your time. Thank you for participating and giving your insights. Thank you so much.
No,
and
appreciate the opportunity, and look forward to speak with you soon.
Yeah, thank you, and thank you everyone for watching. Have a great day or evening, everyone. Bye bye.
Bye bye.